Good morning, all of you. Welcome to GoOnlineTrainings.com. Today, we're going to discuss about indexes, which is very important topic for the developers as well as a DBA. Okay, so indexes are very much important, and you have to give much importance, while exporting data, importing data, while retrieving the data. Okay, the basic question is why is that you have to go in for an index? That is the basic question people would ask. Why is that we need to retrieve? When is that we need to use indexes? The answer is indexes are used for fast retrieval of the data. That's it. If you want to, retrieve the data from a database or from a table, then if you need fast retrieval, then definitely you need to go in for the indexes. Okay. Otherwise, you don't need any indexes. So normally, when you create a table, so I'm talking about a table now. The table does not have any indexes. How do I create the table? I create the table like this. So let me open Excel sheet and tell you. Okay. So I have employee ID, then I have employee name, then I have employee gender. I have, yes, I have started recording it. I have employee ID, I have employee name, I have employee city. So I have, say, employee ID, say, Kiran, I have, say, gender male, and from Bangalore city. Then I
Good
have
morning, all of you.
87,
Welcome to Go
say
Online
Ram,
When you see this,
and
it'll check
male
whether
from
is there a
Hyderabad city.
index here. Yes, there is a index.
Okay.
The next
Then
point
employee ID
is there any
2,
statistics on
John
this column? Yes, there
from
is a
is male
statistics. It'll
from
go for the
Hyderabad city.
statistics and check.
Like that. Okay.
Okay,
Employee ID
female. Female,
76.
I have only
I have
10%.
Anu,
10%, that
and
means I have
she's
say
from
1000,
Chennai city.
2000
Like that, I
pages
have
in the data. I don't know where these
uh,
10% records. So
have Ravali, is a male from say Hyderabad city. Place we have settled there. Vimala is from say Chennai. Like that, I have few entries there. Now, I have created a table. The table name is employee table. The table does not have any indexes, or the table does not have any structure. Okay. If the table does not have any structure, this table is known as, or this table is in heap structure. The table is available in heap structure. In C and C programming, you will say the pointers are declared in heap. Did you come from there? If you come from there, people will say when you declare a pointer, you would get, or the memory would be allocated in heap. Heap means what? Heap means a empty space, or where you can throw the items however you would like to throw them. Okay, heap means unstructured, unordered. Okay, so however you would like to put the items, and you can put it, so there is no way. That is what is known as a heap. Okay, so initially when you create a table inside the database, and now make sure that I did not create any primary key here. You need to understand that. So how did I create a table? I have created a table like this. Create table, say emp. Now I have created employee ID integer, no primary key here. So employee name and varchar 100. Gender, I have taken salary. Employee gender is character 1. Okay, then I have salary. No, not salary, I think. What is that next one? Employee city, say care 5. So this is the table which I have created. Create table employee, employee name, everything. I don't have any structure. So this is the structure I have created. Let me just go to the table and let me drop database test. Okay, I am into the, okay. Now let me create this, a fresh database. Say this use test, and let me create this table. Okay. So I'm just creating this F5. So what happens now? The employee table got created. Select star from EMP. Okay. Now I have got this table. In this table, let me insert few rows. So insert EMP values. So what are the values we have? Values, and let me insert there. Okay. The first value is this, and the single quotes we need to have. Okay, got inserted. So let me take this value also, comma, and so, so let me take this value and insert this into place. Okay, this has also got inserted. Now let me insert this one also. I have Anu, and let me insert this value also, so that you don't have any issues with that. Then we have the last row, which is Ravali, and she is Hyderabad, and we have she is from Chennai. Okay, now I have this data. Let me show you. I have 13, I have 87, I have 2, I have 76, 14, 43. Okay, this is the data I have inserted, and this is the data I have created. Okay, make sure that you don't have any primary key here, and this is the structure I have created. And when you don't have any primary key, or when you don't have any indexes on it, so the present structure is known as heap structure. The table is created in the heap structure. What do you mean by heap? Heap means which does not have any structure. That's what you need to understand. Okay, you need to understand the table is created in the heap structure, created in heap. Heap means what? No structure there. Okay, let me understand and tell you the heap. For example, you are shifting your home from Dallas to some Seattle, or Hyderabad to Chennai. What happens? You get the load, or you get the tractor or your lorry, where you put all your luggage and you go there. You shift from this to Chennai, or this to Hyderabad, or from here to Bangalore. So once you reach Bangalore, what is that you do? Immediately you have to unload the luggage. So when people are unloading the luggage, what they do is they'll dump the data however they would like to dump in your home. So there is no, clear cut this one. So they'll get TV, everything, and in the single place they'll dump it. So that is what is known as a heap structure. Heap structure means unstructured. Advantage if I, use heap manner. What is the advantage for the lorry people when you use heap? They can unload the saman or the luggage easily and quickly. Okay, that is the advantage. But if they say luggage, lorry people, no, no, you need to take all the kitchen saman into kitchen, all the bedroom saman into bedroom, all the TV and other stuff into in the hall. If you say like that, then automatically what happens is the time which takes for unloading the luggage will be more. You have to understand this point. You have to be very clear. Okay, so that means what, when you are shifting the saman, or when you inserting the data from a table, if table does not have any structure, and that is where the inserts are very very faster. So that means what, there are some good things when you don't have structure. Heap, so when you talking about heap manner, so heap here, heap, let us talk about what happens. So we need to talk about insert, delete, and select. Don't have any structure, so definitely insert is very very faster, very very fast. Okay, in the heap. Why? You need not have any structure. You have, you get the row and insert in, and go for the next row. That is how heap always will have, fast for the, insert, and heap always will have, the updates also very very faster. But here few conditions apply. We'll talk about those conditions apply. Let me put some star symbol there. Okay, but even then this is faster, and delete also this is faster, but few conditions apply. So we'll discuss what is those conditions. And select will become very very slow. Why select will become very very slow? Because if I am retrieving data, select star from employee, where city equals to Hyderabad. That means I don't know the city column, the city data may be available in first page, second page, last page, or nth page also. Okay, I don't know how to read the data. Definitely it will be very very slow. It will be very very slow. Okay, now it will read the data a row by row. First it will read this row, then it will go to this row, it will go to this row, it will go to this row, and it will go to that means if it needs some data which has to do a row by row, starting from first row and second row, last row. Okay, till last row it has to read. Okay, this way of reading the data is known as table scanning. Okay, so you need to understand what is a table scanning. What do you mean by table scanning? Table scanning is reading the data from first row to last row sequentially. Okay, so this is what is, you need to read this, then read this, then read this, then read this. Okay, table scanning is very very slow because you don't know where the data is. Why you don't know where the data is? Because you need to insert the data faster, but you don't want to organize the data. So definitely if you need some item, for example, somebody is looking for TV remote, you don't know where the TV remote is. So starting from first room, you need to keep searching, keep searching, keep searching. Okay, so you're lucky if you get it in the room number one itself, or you need to search entire house, because just now you have unloaded the, or you have inserted the data into your new house. Clear? So table scanning is what? Table scanning is, you need to search from row one, from room one to room n. So every rooms you need to search. You're lucky if you're getting the items easily. Otherwise, you're very, very unlucky. It will take lots of time. Table scanning is very, very slow. Okay. When you don't have any structure in a table, the table is stored in a heap manner, or heap, structure. So inserts are very, very faster. Updates are very, very faster. Here, few conditions apply. Deletions are your deletions also very very faster, but only one thing is, only selection is very very slow. This is where the problem you may have it. Okay, but these are the things you need to understand, which will give you very good when you have you know the data in this mode, heap mode. So this is the structure you need to understand. If I have data in the need structure, for example, okay, I have a godown. You take this example like this. I have a big godown. Say it has, say, from 500 rooms. Food Corporation of India godowns. It will be very, very big godowns where you will have lots of rooms there. Single godown, godown number one, and it contains, say, 500 rooms, and you are getting the items and unloading and keeping in the godown. So what happens is you are not, segregating neatly. Room number one should have rice. Room number two should have wheat. Room number three should have soaps. Room number four should have oil tins. Room number five should have, say, plastic glasses. Room number six should have laptops. Room number seven should have TVs. Like that, if you are not segregating it, you simply dump it. Room number one has glasses, plastic covers, dabbas, oil tins, each and everything, every room has. That means there is no properly organized. So you just unloaded the data from the lorry, you kept all the items in all the rooms, but you don't have any clue where your item is. Now, this kind of a structure is known as heap structure. What is the use of a heap structure? Heap structure will, give you a faster response while inserting the data, because you need not follow. You get that oil tins and keep it. You get the wheat and you store it. You get the soaps and store it however you need to store it, and wherever you would like to store it. Nobody will question you. But the problem is, when I need pure oil tins, but you don't have any clue where the oil tins are. You have to search in room number 1, 2, 3, 4, 5. So that's where the issue starts. So when you want to read the data from unstructured heap storage, that's where the problem starts. Otherwise, which are very, very fast. Now what happens? You have inserted the data, then your FCI manager comes and tell you, I need one item. Definitely, it's going to take some time because you need to do the room scanning or the table scanning. So what is that right way to do there? Then once you dump the data, you organize the data neatly. So now FCA people have organizing the data. Room number one, oil tins. Room number two, you say TVs. Room number three, you say some wheat. Room number four, say dusters, marker stationery. Room number five, you have biscuits. Room number six, like that. They have organized the data in the reception of food corporation. They have created an index. What is the index they have created like this? They say, this is the room number they have. Here, they say item. This is the index they have created in this one. So room number one and two have oil. Oil. Room number three, they have, okay. Room number three, they have, say, water cans. Room number four, you have, say, stationery. Okay. Room number four, you have soaps. Room number five, you have something like that. They have easily, organized the data. Okay. When they organize the data, if somebody comes and asks, I need 1 kilo of oil, or I need 2 packets of oil, or 10 packets of oil. So definitely you need not worry about all the rooms. You have to go in for only this room and get the data. Means what? If you want to create a index, if you want to create an index, first data need to be organized properly. This is very clear. Many people, will not understand this point or will not know. If I want to create an index, definitely data need to be ordered, or items need to be ordered, or item needs to be structured. Otherwise, what is that you write? Room number one has oil, water can, stationery, soaps, everything it has. Room number two also has everything. Room number three also has everything. So if the data is organized properly, you cannot, create an index on it. So you have to be very clear. So now heap, when you say heap do not have any structure, so no indexes. But what are the advantages when you go for the heap? Heap is faster for insert, update, delete, but heap is very, very slow when you want to insert the data. Okay. Now heap does not have any structure. But if you don't have any structure, you cannot create indexes. To create indexes, you need to organize the data neatly. Okay, so that's where you will have the organization comes into picture. Okay, so when you create index, automatically the structure is created inside your data. So you have to be very clear on it. So let me go back to our table. Now let me see. This is my table. I don't have any indexes, and sorry, the table is already available here. Now this is the data. However, I stored the data is available like this. Okay. Now understand how the structure is. The structure is however you stored. First 13, next 18, next to 76 like that I have data. But I don't have any, anything here. So everything, however I stored, it is stored like that. There is no structure, there is no story. Now what I am doing is, I am dropping this table. Okay. So let me just dropping this table. So I am creating the same table with the primary key here. Okay. I am creating the same table with the primary key. Then you understand how the and select star. I don't have any structure. Now what I am doing is the first row is 13, second row is 89. Like that I am storing. But now see the structure in this table. So I have inserted. Now see this. Stored 13 as a first row, but it is sorted the data, organized the data. You need to understand this point. So when you create a primary key will create a sorting or primary key will structure the data, which is neatly structures it. Primary key, whenever you create a primary key, what happens is primary key automatically orders the data. So that is a learning point you need to understand. Okay, primary key always sorts the data by default in ascending order. Okay, now see, even though I have stored first 1387 to 76 1443, definitely which is not stored like this, which is storing in a neat manner. So that means when you create a primary key do not have heap structure. Primary key is sorted the data, or a primary key has organized the data. Why primary key is organized the data? Because primary key by default create an index. Okay. Now primary key by default create an index. Now I told you to create an index first you need to order the data. That's what we have done in godowns also. The same thing it is applicable. So why primary key is doing this kind of a organization? Because when you create a primary key creates an index. What is that primary key going to create? Primary key creates a index called clustered index. Okay. When you want to create a clustered index, or when you want to create an index, before that I need to organize the data. Understand the one point. Primary key, creates clustered index on the table. Clustered index we'll understand later, but let us understand what is it primary key done. Primary key creates clustered index on the table. That's what you need to understand. On a table. So it will first step it will sort the data in ascending order. In which column it sorts the data? This sorts the data on employee ID column. Why employee ID column? Because employee ID is the primary key. When you create a primary key, automatically primary key will sort the data and primary key will create an index. Because if it needs to create an index, it has to sort the data. Very simple. The data, otherwise which will not sort the data. Now When you sort the data, then there are some issues here. So let us understand what are the issues when I create an index on it. So now I have the index. So let me have index. If I have any index there. For example, I am inserting a row here. So let me insert a row here. Row I am now trying to insert. Let me take a new row. So I have this is the last row. What is the last row? Say 87. So I would like to insert a row number 41. So 14 number 41 I need to insert. So let me insert this. Now 41 Ravi, okay, from Chen. Inserted. If you insert the row in the structured this one, definitely it is not below, it is in above 40, above 43. Why? You have to create a space for 41. You need to insert in between. That means which is a burden to SQL Server. Why? See, if there is no space, a 14 and 43, if there is no space, first it has to create the space for it. Then insert the data. So that's where it will become slow, which will become very, very slow. If you have any index, when you insert the data, the data which you're inserting, that has to be in the neat order. It has to be either in the ascending order, descending order. Definitely, insertions will become very, very slow. So you're inserting data every time. SQL Server has to check where is the data and how is that, I need to insert the data. So that's where the issue starts. Okay. So this is very, very important point for you to understand. Okay, it's getting hang dating. Okay, now that is a problem when you have the structure. Otherwise, there is no issue. Now, if I am inserting one more row, say I am inserting a row called 1 or inserting row called 12 or inserting a row with 15 like that. If I inserting the data, definitely SQL Server has to do a circus. Why SQL Server has to do a circus? Because the data will be captured in a page. I told you the day one itself. The page may not have, may be having space or may not be having space. So if you don't have the space in the page, how do you insert the data into the same table or same page? It is very, very difficult. SQL Server has to create a new page and which has to insert the data. All of them are internally, the process would happen. Okay, definitely when you order the data, which will be very, very slow. At the same time, for updations also. For example, I'm updating the row itself. For example, I'm updating the key column itself. 14 is available here. I'm updating the key call. So update MP EID equals to say 49, where EID equals to. So when I update the 14, then this row has to come out and the 49 has to go down. Now see the problem. New row, that row should not be there in the middle. So it has come down now. Was earlier, once I changed it because of the sorting order, what happens is it will come down. So that means when you do insert operations, update operations, not only go insert update and physically also you need to sort and take the row from here, go to that room and keep it there. From there you need to keep it here. Because of that, inserts, update, deletions are will become very, very slow. This is also will become slow. Like the deletions also, if you do and automatically this also will become slow, but few conditions apply: update and delete. We'll understand what is that. It will be faster, that is you know uh, select. So if somebody says give me this one, you have sorted order, then you have also indexes, that definitely this will be faster, but all these are will become very, very slow. So you have to be very clear. So you need to understand when should I go in for no index, or no index means heap structure, or when should I go in for indexes. People always will say when you want to read data heavily, when you want to read data heavily, go in for indexes. When you want to write data heavily, then go in for without indexes. So you have to understand this point. You have to be very clear on it. So where lots of writes would happen, actually writes will happen, lots of writes will happen in OLTP. OLTP is the best place where you can go in for the lots without heap, without indexes. OLAP is the place where you can go in for this. So if you need much more writes or much more insert update deletions, that's where indexes are not recommended. That means OLTP will not, recommend for the indexes. But you can have less number of indexes, but you should not have more number of indexes. But OLAP is the place you read and you analyze the data. So OLAP is the place you will have lots and lots of indexes. Okay, so OLAP is, you need to have lots of indexes where writing is very, very less. Once in a year or once in a 6 months, once in a, quarter, you insert the data using SSIS, then afterwards you don't do anything. So you do the analysis for entire year. Okay, but in OLTP, it's not the case. Every day morning, every day, every minute, every second, you will have data from new customers. Okay, so OLTP systems are not advisable to have many indexes. OLAP systems are known as data warehouse systems are good for the indexes. OLAP, or you can also say data warehouse systems. These are the things where you can go in for the lots of indexes. Clear? Questions. So without index, with index, what is the advantage and what is the disadvantage? You have to be very clear on it. Okay. So indexes are good when you want to read the data only, but indexes are bad when you want to, insert data, update data, delete data. So these are the things you need to understand. Create. So when you create a primary key, the clustered index will be created automatically by SQL Server. That internally it would be doing it. That thing you will not be able to understand how it has created, why it has created, everything you don't know till today. Today, I told you when you create a primary key, it will create a index called clustered index on employee ID column or in the account ID in account master table. Okay. So which sorts the data physically, then the problem with the sorting is when you insert data or when you update data, when you delete data, SQL Server has to adjust data depends upon the sorting order, depends upon the value which you have provided. So because of that, insert, update, delete will become very, very slow, very, very slow. Okay. Now, actually, without indexes, the table will read the data in a table scanning. Table scanning means which will read a row by row. Okay. Now, for example, I have 1, 4, 5, 6, 7, 8, 9. Like that I have lots of data. Okay. Say I have some hundreds data. Now, if I want to reach 100 here, the SQL server will come here and come. So it will read, keep on reading till it reaches 100. Okay. So this is what is known as a table scanning. Table scanning means continuously reading from row 1 to row 100 or row 1 to row n. Okay, so how many reads I have to waste? I have to waste 99 reads I need to waste to reach 100. So that is the problem while retrieving the data. So I need to, waste 99 reads. So if I am wasting 99 reads means which is very, very slow. I don't know if I have 1000 rows or 2000 rows. If somebody asks, tell me where account ID equals to 1000 or 10,000. So how many reads I need to waste? I need to waste so 999 nines if I have, 1000 is the data there. Clear? So to overcome this issue, what is the overcome this issue? We are doing a table scanning here. Table scanning, read from first row, second row, third row, fourth row, fifth row, sixth row, seventh row. Like that, we have to go and reach the whatever you needed. Okay, so here you are going to waste 99 reads, which is very, very slow. Overcome the table scanning, then that's where you have to go in for the indexes. Okay, the first index the SQL Server creates is clustered index. When you create a primary key which sorts the data and which creates an index. Any questions till now? Let me go back here and what is a clustered index? How the clustered index is used? Index, how clustered index is used? Okay, so now I have created a clustered index. Okay, now I'm going to show you once again. Let me drop this table or alter this table and remove. So let me drop this table. Now the data is, make sure that the data is in sorted order. You have to very clear 1, 2, 13 like that. Even though I have inserted 13th record first. Now I'm going to show you once again what is the heap structure. So I have dropped this table. Let me remove this primary key here. I don't have any structure. So this is a heap structure now. So I don't have any data here. Insert. However you insert the data will be inserted as it is. Now see the structure here. The first is 13. This is the first row. Next 87. Next 2. Next 76. So however you stored it, it is stored just like that. So here there is no indexes. Okay. How do you find out the indexes on a table? Indexes on a table, you have to use this command to find out indexes on a sp underscore help sp underscore help access 18 index. We have to provide here table name. So what is the table name? Table name is emp. Okay, the object emp does not have any indexes. That's what it clearly says. Or you do not have any permission. I have the permission, but I do not have any index because the emp table do not have any primary key, so which does not have any index. Hence the data is stored in which manner? The heap manner. However you stored the same way the data got captured. Okay, you can also go in for index if you want to. Otherwise you create a index or create a primary key, foreign key, or you can. So let me drop this table, and what I am doing is I am planning to include a primary key here. Primary key will create an index. You can alter the column and add a primary key also, so that is not the issue here. So I don't have any data. Now I'm inserting again same order, but the order will not be the same in the table. The order you will have in different. Now see this. Okay. Now the data is sorted. Now let me see the index whether do I have any indexes here. So sp underscore help index. Now I have index and which is a clustered index, and a clustered index unique and primary key located on primary file group, and index key is employee. That you can understand the index also here. Index table name which will tell you if you have any indexes. If you want to create indexes also, you can create indexes using create index name. Then you have to provide the table name and all. So you should be able to create an index. That is also done. Create an index, then definitely index will be created. The index is available here. Now you should be able to understand how we can create an index there. Okay, now you need to understand what is the clustered index and how the index pages are allocated. Okay, let us understand now. For example, I have created this index. Now data is sorted, entire data is sorted on this. So how the data would be sorted? So let me use this function here. So expand the selection. So data will be sorted like this. Okay, it has come down. So let me insert some. It has taken column names, everything down here. So let me. So this is Excel way of handling. Don't worry. This is not the original way SQL Server handle it. So this is EMP tape. Okay. Now I have sorted the data. When you sort the data, this is how the data is also available in SQL Server. Or sort the data physically. First we have John, here also you have the John, same thing. Okay. So everything got sorted. So this is how the structure you have index. So when you create index, cause SQL Server will create index pages physically. So sorting is one thing. Then we have also created this kind of an index in the godowns. That's what we told. Now indexes are physically created. So index pages are physical page created and which are there everywhere. Now when you buy a book, book will have indexes. Do you understand indexes or not in the book? Table of content is it? Nothing but index. So you need to read chapter number 22, or you would like to read chapter number triggers. So you need to find out which is the page in the triggers are available. So you read the index and you jump there. So what happens? The table scanning need not be done. Otherwise, what you have to do? You have to go to page number one, page number two, page number three, page number four. You will be keep on reading using a table scanning or book scanning you do. But if you have a table of content, you would like to do the you will go to the index and check for the triggers, then see the page number for the triggers, you will jump there. So index pages are physical pages which are created and clubbed with the data pages. So in the MDF file when we created, okay, MDF file when we talking about SQL Server architecture, MDF file will have pages. This is page number one. So this is MDF file. Let me take this file. MDF file. So I have few pages are data pages. Now these are the data pages. These could be in that I may have index pages. So here and here I may store indexes, but all these are called data pages. Okay. Now .mdf file will have two kinds of pages. One is index pages and you may have data pages. Okay. When you have a primary key. So everything got stored in physically, that is as part of MDF file or as part of the NDF file, data file, MDF or NDF files. That's what you need to understand. So data plus indexes are stored in a single file only. It will store. So when you buy a book, you have index pages, you have data pages, both of them are clubbed and it will be there physically. Indexes also you need to have you need to have space. You have to remember this. So if you have 400 pages in your book, then table of content will take another 20 pages. So total pages are 420. Have 1,000 pages in my data pages, and definitely I may have some 100 pages here. Total 4,000 plus 100, 4,100 pages. But for 100 pages also you need to have a space. So definitely index will consume space in the hard disk. You need to understand. Okay. And where the indexes are stored, part of MDF and NDF file only. Okay. Log file will not have any indexes, so don't worry about it. Now, when you create a primary key on this column, data is sorted. Now, index is created. Let me show you how the index is created. So, let me show you the clustered index structure. Clustered index structure. Now, clustered index structure is called B tree structure, binary tree structure, tree structure. Okay, you have to understand what is B. B stands for binary tree. Okay, understand. This is B tree. Clear? Let me delete this. Now let us understand. The clustered index will have a root node and the clustered index will have some other nodes. Okay. So let me open a paint and let me give you the clear cut picture. First, you will have a root node here. And once the root node is done, you will have what is known as, okay, I have few more, okay, like that. I'll have few more branch nodes here. I have one more page and one more page and one more page, one more page. Now we have to go down and create. This may have a few more. Okay. So let me still insert this. Okay. So below also I may have few more index pages. I have some more pages which are got. Okay. Now I may have a few more pages here, and like that you will have data which is got located. Okay. Now, okay. Now this will have like this. The data here, and this has the data here, and this has the data here. Okay. Be there. Again, you can link it with this. So like that, you may have. So let me not. Okay. So this may have three more pages or five more pages. Like that, the data is stored. Okay. The starting is you will have a root node here. Is a root node. Then these are nodes are intermediate nodes are intermediate nodes, the branch nodes, okay, are branches, all of them nodes are branch nodes, and the down one here you have leaf nodes structure. So leaf nodes will store the actual data. Intermediate nodes contain index, and root node also contains index. Okay, so this is how the data going to be organized. Going to be organized. Understand how the data would be. If I have data coming from like this, say how the data is organized like this. 1, 2, 3, 4, 5, 6, 7, like that. I have say thousands of rows. The root node will have data like this. Root node will have, it can say like this. So let me divide this into parts. Okay. Now it will have 1 to 100. 1 to 100 data is available in page number 1. 1 to 200 data available in page number 2, like that. Okay. So this is page number 1, number 2, page number 3, and this is page number 4. So everything will have page number 1, 2, 3, 4, 5, 6, 7, 8, and in extent number also you can have. Again, extent number 2, 1, 2, 3, 4, 5, 6, 7, 8. Like that, you will have indexes. Okay. Now you come down, and here also you can have, page number 1, page number 3, and page number 4. Okay. So pages are, part of extents, right? So extent will have 8 pages. So extent number 1, 1, 2, 3, 4, 5, 6, 7, 8. Extent number 2, 1, 2, 3, 4, 5, 6, 7, 8. Like that it will be there. So don't worry about it. So as of now, it will. So 1 to 100, if you need, go to this one. So here 1 to 100 means, again it will, split the data like this. Okay, let me take 1 to 10 data available, page number 1. 11 to 20 data available in page number 2. That 21 to in page number 3. Like that it will give you. Down here, this is page number 1, this is page number 2, page number 3. In the page number 1, you will have the physical data. What is the data you will have? Page number 1 to 10 data is stored here. Okay, so I have only one thing, this will get stored here. 2 John M gender, so which will go here, is got organized 2, and M. If you have the 3 also, then put some, say, and here M, and say Chennai. Like that, if you have data, the data would come here. The 13, 14 data would come here. The 11, 10, all of them. 11, 12, all the data would come here. 13, 14, like that. Okay. So 1, 2, 3, 4, 5, 6 data would come here. So 11 is say we have Kirana and all of them. Okay. So this is how the data is organized. Okay. Now if somebody comes and asks a question saying that select star from an employee where employee ID equals to uh, say 5. Select star from employee where employee ID equals to 5. First which comes here, employee 5 is less than 100, which comes here, and from here it will jump into 1. 1 it will jump into again down 1. So here it will scan this page. So it will read 1, 2, 3, 4, 5. From this page it should be able to get the data. Okay. So the data organization is like this. Data retrieval is like this. First which will jump here. So after jumping here, you jump here. So select star from employee where employee ID equals to 1. 5. It will jump here. From here, it will jump here. It is less than 1 to 10. It will be there in this box. It will jump to this page. This page, this it will scan this page. That means which is eliminating remaining pages. So initially we were talking about you need to go here, go here, go here. So the all these pages are eliminated. So now you're not doing any table scanning here. You're going here, coming here, and jumping into the data pages. Pages are completely ignored. So this is how you can have or improve the performance when you have a clustered index on it. Okay, these pages are stored in like this. So this is a binary tree, B tree structure. You will have a root node and index, and you have the intermediate node, root node, and you will have leaf node. Leaf node will have index. Leaf node will have index, and these two are called index pages. This is very clear to you. So this is how we need to understand a clustered index. Clustered index is a physical index which got created automatically when you create a primary key on it. Okay. So you may ask a question in interview. I need a primary key, but I don't need index on it. Can we create a primary key without index? Is there any code which can do this job? The answer is no. I need a primary key. What is the primary key responsibility? Primary key will ensure that duplicates are not needed. That is the primary key's job. But people will would ask in interviews, I need a primary key, definitely. I need that functionality. But what I don't need a index on the primary key. Okay. Can we create a primary key without index? The answer is no. Automatically, the index will be created. Okay. So he will ask you a question like this. Create a clustered index without a primary key. Can that be possible? I need a clustered index, but I don't need a primary key. Can that be possible? The answer is yes. Even though you do not have a primary key, you can go in for the clustered because index is different, primary key is different. Okay, index is different, primary key is different. The primary key will give you index as a free of cost. That's it, which is doing extra thing for you. Okay, but if you need a if you want to create an index, that is also can be done using, you can also create an index, but you don't need any primary key. That is also perfect. So you can go in for index without having a primary key, but you need to use a syntax to create a primary key. Okay, the question is how many clustered indexes we can have per table? One clustered index per table. Okay, why we can have only one clustered index per table? Because when you sort the data on this, when you create a primary key on this, sorted. But when you create another clustered index, data need to be sorted on this. Happens to this structure. So definitely this structure goes. So the important point is that always you can have only one clustered index. Okay. So clustered indexes, few more points we need to understand. What are the points we need to understand? So point number one, point number can we create PK on a table and data gets in ascending and X is created. Okay. Now, how do we see indexes? Use sp underscore help index help. Then will name. ठीक है. Then one clustered index per table. Index per table, we cannot have many more. The question is, can we have a primary key without any? The answer is no. Can we have a primary key without having any index? The answer is no. Next question is, create an index manually. The answer is yes. Okay. Now the syntax to index, we have to get it. Okay. So if you don't have the clustered index or if you don't have anything, then definitely we have to create an index. Okay. How do we create? We have to say index, then you have to provide name, then you have to provide on which table you would like to create, then open the bracket, close the bracket, on which column you would like to create. Now we need to understand which column you would like to create the index. Okay. create index, index name on a table name on which column you would like to create an index. So let me just create one index and create, if you want to create a clustered index, you have to put clustered index name, then you can do that. So, okay. So only one clustered index, you cannot create one more. If you create, it will give you, the errors. So I have an index on here. So where is that? We can see the index here. I have the index because I have a primary key here. So let me drop the table once again. And now I am creating a primary key. I am not creating a primary key. That means I don't have any index. I don't have an index. Let me create now a clustered index on it. Clustered index will sort the data. So let me insert the data here. Now read the data. The data is in heap structure. Now let me create a cluster and I don't have any primary key. Please remember this. I don't have any primary key, but I'm planning to create a clustered index. I have the data already. So what is the code we have written? So control C, control create index. So as clustered RED. Okay, create clustered index name index 123. I'm giving some index 123 is the name. And on which table I'm planning to create on EMP. I would like to create on EAD column. Okay, EMP. Yes, we have this column. We have the data also here, but data is not organized. Okay, let me go in and create file. So command completed successfully. I have got the index. Now let me see the index. Now index is created. So this is I123 is the name clustered located on the primary on this column. Now data would have been sorted. You have to make sure that the data whether it's sorted or not. Data is sorted to 13, 14, 43, 26 like this. That even though if data is available there, it will sort it. Otherwise, when you insert, it will sort it. So here there is no primary key. Make sure that which will not have any primary key. That means which will have duplicates now. Okay. Can I insert a row here? Let me insert this row. 13 which will take it because which do not have any do this one primary key. I have 13 and 13. There is no issue here because the clustered index is not responsible for checking duplicates. Clustered index, if you have the same data, which will sort it and create. It will say that 13 is available and 13 also available in the same row. That's it. So many people will confuse. Clustered index will not duplicate. That is wrong. Index is different, primary key is different. If there is a primary key, it would have been asked you, hey, why are you inserting duplicate data? But a class index will not ask you. Why index is different? So you may have duplicates also. I don't have primary key, but I have the duplicate data. Here, clustered index is created, but you may have duplicates there, but you don't have any primary key. So this is a faster. But what is that you cannot have? You may have duplicates. Only for that we need to go for a primary key. Otherwise, also you can create like this. Create. Okay. You can see what is my index by seeing this button. How do I create another index? That we'll see. So as of now, we discussed about only one thing, why we have to go in for index and what is a heap and what is a table scan and how many clustered indexes per table you can have and all of them we discussed so far. Okay. So we have to be very clear. Okay. So tomorrow when we come, we're going to discuss about some more indexes. We have one more index called non-clustered index that's we're going to discuss tomorrow. Okay. So types of indexes in SQL Server, we have one is clustered we have non. Okay, tomorrow we're going to talk about non-clustered indexes. Okay, only these two types of indexes are available in SQL Server. Today we had known the clustered index. What is the clustered index and where will it be? And tomorrow we're going to discuss about why we have to go in for non-clustered index and why is the clustered index is not sufficient and when we have to go in for this one. So do you have any questions to be asked? So please remember only one clustered index per table. That's it. Or we'll wind it up. So tomorrow we're going to discuss about what is a non-clustered index. Do you have any questions, guys? So we will continue with the non-clustered indexes. Many questions would be asked in interviews, even though indexes are not maintained by the developer. DBAs have to take care, for indexes. But even then, developers are asked lots of questions on indexes if you don't have a clear-cut idea. Okay. So index pages are physical or logical. Index pages are physical. Where will it be stored? It will be stored along with the data pages in your MDF or NDF files only. Okay, you have to be very clear on it. So thanks, Chris.